Inductive reasoning starts our logic unit out. All math is studying patterns and making conclusions off of those patterns. So that's how we have all of the math rules that we do is somebody looked at what was happening, what was going on consistently, and gave us some rules. So let's look at some inductive reasoning. So inductive reasoning is making a conclusion based on, look at that. See what color I got today. Based on observations and patterns. And so conjectures are conclusion statements reached using our inductive reasoning. Inductive reasoning. Okay, so I'm sure we've all seen these, and this is why our bonus activity was those pictures. What you were doing with those pictures were figuring out the patterns. Based on these patterns, the shoes were, if there was 2 of them, there was 20. If there was 1, there was 10. So that's what you guys were already doing. So this is kind of something similar. And I know you've seen these in the past. I remember doing these a lot. Find the next 5 terms. Find the next 5 terms of the sequence and then describe the conjecture. So we're going to look at these numbers and figure out what's the pattern. And if I look at these closely enough, adding something to them doesn't really give me anything. But what about, are these numbers all squares? 1 is a square of 1. 4 is a square of 2. 9 is a square of 3. 16 is a square of 4. So what's the square of 5? 25. What's the square of 6? 36. What's the square of 7? 49. And what's the square of 8? 64. So our conjecture is each term is a square. Term is a square. All right. So we got 2, 5, 11, 23, and what's the next 5 terms? Looking at these, if I take 2 plus 2 and add another one, that gives me 5. So maybe if I take 2 plus 5 plus 1.
Thank you.
Sorry, guys, I picked an awful time to film this, but I'm not going to start over. So what I was saying was if I take 2 plus 5 plus 1, that gives me 11. 11 plus 11 plus 1 would give me 23. So it looks like I am doubling my term. So then this would be plus 23 plus another 1. So that would be 47. And if we do that math all the way, 191, 383, 767. So our conjecture is, what do? We doubled the previous term.
That's route 1022. You're up. And the rest can exit as well.
Previous term, and then we added 1. All right, that's all that is. Look at your numbers and how could we get to the next number based on everything that's there. We're just finding the patterns. All right, counter examples. Counter examples are an example that shows a conjecture is false. So this is like maybe we have a conjecture saying something that, okay, that's trying to say that it's true, but then we're like, wait a minute, we have an example that makes it false. So that's a counterexample. So let's look at these examples. The conjecture is all apples are red. So this statement is trying to say that it is true that all apples are red. Well, is that true? No, it is false. And what is our counterexample? Well, our Granny Smith apples, wow, apples are green. So there is our counterexample. So you're going to be asked, not only is the conjecture true or false, but then if you're saying it's false, you have to give an example. You have to tell me why you're saying it's false. All right, conjecture. If A times B equals 0, then either A or B equals 0. Is that true or false? Well, remember, for a product to equal 0, one of them has to be 0. So this one is actually true, and there is nothing else I need to do. All right, let me know when you have questions on that.